Okay, so look, I'm going to talk fast, all right? That's what I do. You guys might find it mildly entertaining. We'll see. We're going to talk about the machine tool work group. Actually, we're not, because we know about it. We're going to talk about me. That's really important. And we're going to talk about hardware, software, and standards. And basically, my plan here is to predict the future of the world. Okay? We're going to skip through this. So let's talk about me. I like talking about me. My first job in the business was I used to solder wires onto harnesses that were doing it for test equipment for the auto companies. That was my first job in factory automation. I became an electronics technician. I used to do field service and stuff like that. I became a maintenance engineer and started diving into CNC back in '84, '85. Design controls, ultrasonic scanners, a bunch of different stuff. In 2005, I traveled up to Sid suckered me into traveling up to Seattle and starting work at Seattle on the 787 program up at Boeing. Work on CAD/CAM side of things mostly. Mostly a software guy, not a hardware guy. I became an associate technical fellow, which means I'm very important at Boeing in 2011. One of my side jobs is I'm the chair of this work group, and been working with the step manufacturing stuff for a while. So my background's really unusual because I've been I'm old and bitter like John. You know, I've been around the block a few times as far as stuff is concerned. And I've always kind of felt that I've operated in the reality-based world, and there may be some disagreement about that. And so what I'm going to do is predict the future, right? I'm not predicting the future as a Boeing engineer. I'm predicting the future is not Boeing's position here. This is my personal position and observations based on what's going on and what I see coming, okay? And I thought it might be interesting. So who knows what's going to happen, right? We could have something really disruptive. Anyone want to identify the picture to the lower right? That's a very important smokestack. It's in Italy, in Vatican City. Right, you know, so, right, you have your new pope, right, so no one was really expecting that, right? We have these really disruptive things that happen, right, and that changes how stuff happens. Or by a snowstorm, I'm not sure how many people got stuck in the snow. So we have these disruptive things that happen. We have technology that drops the middle and really changes how things go, and then there's stuff that just we kind of see improving. Kind of like how's the cost going to go down for the polymers that we're using, right, to do the 3D printing or the lay-down stuff. But it's one of the purposes of ARC and one of the purposes of OMAC is that everybody wins when we all talk to one another, when we all try to see what's going on in the future. You guys all know what a computerized numerical control is. This is my opinion about embedded PCs. This is the history of embedded PCs and CNCs back in the 50s and the 70s. It was numerical control. There's no C, right? That's what the first C is in numerical control. In the 70s and 80s, you started to see proprietary computers. The old Cincinnati Big Blue Control had was a data processing. Cincinnati Millicron, I think, had a data processing business for a while, and the actual computers that they first started using was one of their data processing computers that they had designed that worked into their control. And so in the 70s and 80s, you started to see controls as part of the CNCs. Sometimes they were just doing operator interfaces, and sometimes they were integral to the actual control algorithms, and sometimes it was a mix. But in the 1980s and the 1990s, the end users started to rebel. This is, I guess, the Star Wars Rebel Forces. So you can see how nerdy you are. That's what that is right there. And people started asking the questions, why am I paying a CNC manufacturer $15,000 for a megabyte of RAM? You know, why can't I go to the Radio Shack and pick myself up a floppy drive if my floppy drive dies, right? And then why aren't these open? Why is everything proprietary? Why doesn't anybody want to play with everybody? So the end users started to rebel, and that's kind of where OMAC came from, actually. Industry responded by creating OMAC, right? And the original purpose of OMAC was to develop a control that was open architecture and it was based on the IBM PC platform. My personal opinion is that that was a mistake, that they should have based it on software and communication standards, not on a given piece of hardware. But that's what they did. Big end users like Boeing and stuff said, we want IBM-compatible PCs on these things. And basically, you got two responses. One was that people would take an IBM PC and make it a front-end interface to the CNC. The CNC was still basically the same. In other circumstances, people would integrate a PC with the CNC. Kind of saw two ways of that happening. PCs and CNCs, so this is the old bitter guy, right? PCs are really cheap. They don't cost much at all. A lot of people know about them. You get a lot of bang for your buck, and the interfaces, the graphical interfaces on them are real powerful and really, really useful. Negatives on it are your hardware life cycle is a complete mismatch to CNC machine tools. Right? You buy yourself a PC, within 3 months they're not making it anymore, right? The cycle time, you run 3-4 cycles of PCs in a year, and a typical CNC machine tool you're going to run for 20. Software is the same issue, right? The operating systems that are out there, we've got machines at Boeing that are running BASIC, lots of them, right? Because we keep a machine for 20 years, operating systems change every couple of years. Viruses were a really big player. Right? Viruses started showing up in the 90s. We started getting in trouble with viruses, and we had to protect for viruses, and that was difficult. PC is a different world. It's not a machine tool world. It's a different sort of a nerd. And the fact that the interfaces are so powerful is also a negative because again, that's a route for viruses or someone wanting to load a flight simulator on your CNC machine tool, causing problems. Form factor is an issue too. If you look at the actual PC, it's designed more for economy than industrial robustness, using regular edge connectors and stuff aren't as reliable as plug and socket type connectors. So the PC as a front end, basically you had a separate computer that was running the CNC, and the front end itself was just doing operator interface. It really becomes an issue with security stuff, right? If you're going to run virus protection in this thing, when are you going to scan? You're going to scan in the middle while you're running a program, and you say, sorry, you'll have to stop running your part for a while, or you won't have an operator interface to use for a while because we're going to scan for viruses. Networking security became an issue, and again, you get the issue of obsolescence, right? If you buy a CNC that's got a Windows front end on it, you can bet that operating system is going to be obsolete within a few years, and that machine's going to be running for a longer time with an obsolete software on the front of it than with anything that's current at all. So some people then did integrated PCs as the controller itself. Now the problem is that most operating systems that are available for PCs aren't real time. So there are some people that made some real time kernels, and basically they're using the PC as the actual NC itself. They tend to use industrial grade hardware when they do this. If you look at the typical fan that's cooling the CPU on your PC, it's got about a 5-year design life because it's got sleeve bearings on it. And it's just designed to ride for about 5 years, and then the fan's going to quit working, and everything's going to overheat, and it's going to quit, right? If you put a ball bearing fan on that thing, it's going to cost you another $15, right? And that ball bearing will probably last, a ball bearing fan is going to last about 20 years. Well, if you're a PC manufacturer and you're trying to beat the prices, right, you're going to save that $10, right? If it's in the industrial world, you're going to want to have them pay the extra money for it. There were several failures and several successes. One I would call as a success is the Akuma, the Think Control. They're not here today. I was hoping they'd be here today. Their philosophy is it's an industrial PC, but their philosophy is it's okay to change it out 3 or 4 years, to have a reasonable plan that you can change out the actual hardware itself, upgrade to new stuff, and not have to retrofit the entire control. The emphasis from Think is openness. They took a lot of inspiration from OMAC on it. But it handles the real-time tasks, both in hardware and software. I think they're successful because they understood machining culture, because there are machine tool guys that were developing a control. Instead of PC nerds are saying, hey, I can make a pile of money out of doing CNC controls, and they don't really understand the culture. You had some real passionate guys that were behind that, one in particular. So this is my prediction, right? This is my speculation, right? I'm starting to see, I don't think that you're going to see as many PC front ends on lower end controls anymore. They're starting to go away. For example, Siemens, the latest version of the Siemens control, they've moved to Linux instead of a PC front end. You can still get a PC front end, but you got to pay for it. All most people care about is networking, being able to hook their machines up. Right now, that's the prime thing that people care about. And standards like MT Connect are hardware, software neutral. There's no reason you can't make MT Connect work on a Linux box. Right, John? I think that we'll see more use of integrated PCs on the low-end controllers. It's just so crazy cheap. The technology is just so crazy cheap to use in embedded PCs. And you just look at the compilers, you look at the Visual Studio Suite compared to something else that you're going to use. It's just huge value and huge capabilities for your money. And now that real-time Linux is out there, I think you may see a takeover, a significant number of low-end CNCs that are running real-time Linux. Yeah. There's several manufacturers that sell a real-time kernel for Linux. I don't think Red Hat does, but there's several that do. Right. Yeah. They'll buy that real-time Linux and they'll use the rest of the Linux capabilities with it. So let's see here. Here's the thing I think is going to go on with motion control, kind of in the hardware world. Back in the 1950s through the 80s, the way that you communicate with a servo motor was either plus minus 10 volt analog signal or step pulses. You're drawing step motors. To the 90s, there's a lot of proprietary network protocols that are being used to drive access drives on motion control. Surcos came out in the 1990s. It was fiber optic. There's not been a lot of penetration of Surcos. I think one of the reasons is because it was fiber optic. They've introduced a new version that runs on Ethernet. But there's always been like two separate worlds, just like Lucy and Ricky in their beds, in that the CNC motion control was the high performance, fast, tightly synchronized stuff, and general motion control was less expensive and the performance was a lot less. One of the reasons we got all these people on the other side of the wall over here is that the general motion control has gotten so much faster, so much higher performing that they're able to replace all the gears and drive shafts and stuff to synchronize machines with it. So the performance has gone way up. So you got this issue in that the CNCs are getting faster, the motion control is getting faster, but so is this general motion control. And if you look at a lot of their hardware now, they're sharing hardware, right? They're sharing AC servo motors. And I wonder when these two worlds are going to come together. Yep. It's culture too, right? And you think about it, you sell a guy a CNC, there's some certain level of support that the supplier is expected to provide, right? As versus someone selling a servo motor and a drive package to a third-party integrator, and it's a whole different level of support, and so they've got different pricing models. Yep. I think the impasse is going to continue. I think they're going to stay two worlds for a while, even though they're sharing products. That's my guess. Although I wouldn't be surprised if some upstart said, let's see. I can buy myself a motion control system, right? And I can hook a real-time PC with a front end on it, and I can make them play together really nicely because a lot of your real-time... Yeah. Might happen. I don't know. The idea of someone coming, the thing is right, it used to be right that you bought your machine and you bought your CNC, right? I'm going to buy my machine from supplier A, and I want you to put supplier B's control on it. Fat chance to you telling them to do that nowadays, right? Maybe retrofits. Robots versus machines. You know, we've been talking about why should I pay all this money to buy a big old CNC machine tool when I can get a robot for a lot cheaper? And there's been a lot of, I would say, false starts and stops as far as that, and a lot of failures from various folks who've tried to put robots in a machine tool world. They're different cultures. In robotics, they tend to talk about repeatability and substitute that for accuracy. In the machine tool world, we say accuracy is going to a new known random position. But there's a lot of talking about it. There's a lot of conversations. There's been a lot of efforts on it, especially if we're talking about really, really large-scale stuff. Yeah, Fred? Part of the issues, too, is that we look at giant reaches, right? Let's say if I want to machine a fuselage directly, right? I'd have to have a massive, huge gantry, traditional Cartesian CNC machine tool to do that. Could I do that with a robot? We're going to quit early. We're going to quit in just a minute here because we need to be next door, so it'll kill me otherwise. I see that there'll be some slow penetration of robots in the CNC machining world, as long as people are really smart about the applications. For me, I see drill and fill as being a big idea. That is, you drill a hole and then you shove a fastener in it. You think of all the fasteners, even a 787, which has many, many less fasteners than a traditional airplane model, still has many, many thousands of fasteners putting it in. So that's my prediction is what's going to happen with that end users who are really, really smart, really, really savvy will be able to do the sorts of stuff like Fred's talking about, which is use them successfully in limited environments. Robots are so much cheaper. And if you look at their mean time before failure stuff, which I never really believe all that much when the numbers get so low, they're very, very reliable because they're tightly integrated. Anyway, Oh, come on. You don't know what that is? It's the 8-ball, the magic 8-ball. Yeah. So, yeah. So, anyway, we need to go next door. And then if you want, we can finish up some of this. Okay?